Hello everyone. This is the second video of chapter 5, and in this video I'm going to discuss the second learning objective of this chapter. Essentially, we will be talking about annuities, perpetuities, and their valuations. So we will frequently encounter situations where we have multiple cash flows that are all the same amount. For example, a common type of loan repayment plan calls for the borrower to repay the loan by making a series of equal payments for some length of time. Almost all consumer loans, for example, car loans or house mortgage loans, feature equal payments, usually made each month, right? More generally, a series of constant or level cash flows that occur at the end of each period of some fixed number of periods is called ordinary annuity, okay? Or in a more general term, if we want to define annuity, annuity is a stream of cash flows occurring at a regular interval for a fixed time period, okay? Now, if the cash payment occurs at the end of each period, then it is called ordinary annuity. Whereas if the first cash flow comes at the beginning of the period, then it is called annuity due. Okay, so for example, if this is a 3-year cash flow, for example, 1, 2, 3, if the cash flow starts at the end of our first period, for example, this, then it is an ordinary annuity. Whereas if the cash flow starts at the beginning of the period, then it is called annuity due, okay? And if this cash flow expected to continue forever, then it is called perpetuity, which means that the main difference between annuity and perpetuity is annuity cash flow continues for a fixed time period, whereas perpetuity continues forever. Now, let's see how we find the value of an annuity. Okay, look at this example. After carefully going over your budget, you have determined you can afford to pay $632 per month towards a new sports car. You call up your local bank and find out that the going rate is 1% per month for 48 months. How much can you borrow? So you pay $632 per month for 48 months, and 1% is the monthly interest rate. So against this payment, how much you can borrow now? Now, if you remember, we learned about calculating the present value of multiple cash flows, and there we have seen that we can calculate the present value of individual cash flow and sum them up. But when this number of cash flow is long, for example, you see 48 months, number of cash flow is very high, then it is very difficult and time consuming to calculate the present value of each cash flow and sum them up. And that's why we have a formula, which is essentially a shortcut that we have seen in the previous slide. You can see, so this is the formula of present value of an ordinary annuity. Okay, so instead of calculating the present value of individual cash flow and summing them up, we can use this formula. So you see 632, which is your periodic payment, then 1 minus 1 plus 0.01, which is the interest rate, power t, which is 48 months divided by the interest rate once again. And you can see that the present value of these ordinary annuity is 24,000. Okay, so this is how we can find out the value of an ordinary annuity. And keep it in mind that this formula is used when you have an ordinary annuity. That means the same amount of cash flow is coming at a regular interval, and that continues for a fixed time period. You also can use Excel spreadsheet formula. Okay, now in the previous problem, we have found out that if we know periodic payment of an ordinary annuity, what is the present value of this annuity payment? Okay, Now, this problem is about finding out this annual payment. So instead of finding out the present value of the whole cash flow stream, we are finding out the periodic payment in this example. So look at this. Suppose you want to borrow 100,000 for 5 years to buy a new car, and you can borrow at 8% per year. So what is your annual payment? So you're going to borrow 100,000, which means that is the present value of your annuity payment, okay, for 5 years. 18% is the interest. So you need to find out what should be your periodic or annual payment. Okay, so this is just a rearrangement of the formula. You remember the formula that we have seen here. So present value is the periodic payment, and then this present value annuity factor. So we bring the periodic payment in the left-hand side. You can see that that is the periodic payment, and this is the present value divided by present value annuity factor. So our present value is 100,000 divided by this annuity factor, and we find out that our periodic payment is 31,978. It means that if you make an annual payment of 31,978 and you pay 18% interest, so you can borrow 100,000. Okay. So in the previous two examples, we have found out the present value of the annuity payment, the periodic payment, and in this example, we see how we find out number of payments. Okay. So look at this example. $1,000 is due on a credit card, and payment is $20 per month, and rate is 1.5% per month. How long would it take to pay off this $1,000? Okay, so you know what is the total payment, 1,000. You know that periodic payment is $20 per month, and you know the rate is 1.5%. So how many payments you have to make to pay these to pay off this $1,000? Okay. Now you can see that once again we just rearrange the equation. So 1,000, that's the present value. 20 is the periodic payment, and this is the present value factor. What we don't know is t, so we need to solve for t. Okay, so once again we use the logarithmic function. You remember we used this logarithmic function previously to solve for t, and we see that it will take 93.111 months or 7.75 years. So it means that you will need almost 8 years to pay off your $1,000. Okay. And now, how do we find out the discount rate or the interest rate associated with that annuity payment? So look at this example. An insurance company offers to pay you $1,000 per year for 10 years if you will pay $6,710 upfront. Okay, so you have an offer that you get $1,000 per year for 10 years if you provide upfront was 6,710 now. So you want to know if you accept this offer, how much interest actually you are getting. Okay, so we can solve this using just rearranging the equation. So we solve for I, the interest rate. And this is how we can solve it using the Excel spreadsheet. So if you want to calculate the rate, I mean the example that we have seen in the previous slide, without a financial calculator, there is no straightforward way to finding out the rate. You essentially need to do a trial and error method. Okay, so trial and error method means, first of all, you need to choose an arbitrary interest rate, then you compute the present value, okay, based on that arbitrary rate. And then this compare this present value with the actual loan amount, okay? And if you see that your computed present value is greater than the loan amount, then the interest rate is too low, whereas if the computed present value is less than the loan amount, then interest rate is too high. So you have to use another interest rate to make this present value close to the actual loan amount. Okay. So you need to continue this process until your computed present value and the actual loan amount are equal. Okay, now annuity due. I already defined annuity due, and as I was saying that so far we were talking about ordinary annuities. These are most important, but there is a variation that is fairly common. So in ordinary annuity, as we have seen, that the cash flow occurs at the end of each period. Okay, so when you take out a loan with monthly payments, for example, the first loan payment occurs 1 month after you get the loan. However, when you lease an apartment, for example, the first lease payment is usually due immediately. Okay, and the second payment is due at the beginning of the second month, and so on. So this example or this type of cash flow is called annuity due. Okay, so again, the same amount of cash flow is occurring at a regular interval for a fixed time period. However, the first payment occurs immediately. So that is called annuity due. Okay. So now we have seen how do we calculate the value of an ordinary annuity. Now let's see how we can calculate the value of an annuity due. Suppose an annuity due has 5 payments of $400 each, and the relevant discount rate is 10%. So calculate the present value today. Okay. You can see this present value interest factor of an annuity that is pretty much the same we used previously, but due to this annuity due function, we have one additional component here. Okay, so if I show you the previous formula was this. You can see just this present value factor, whereas in this case you have an additional component. Okay, additional component, which is 1 plus interest rate. And 400 is the periodic payment. So the present value is 1,667.95. That means 5 payments, $400 each. If the discount rate is 10%, the value of this cash flow today is 1,667.95. Okay, so this timeline shows that how annuity due cash flow occurs. So the first payment occurs immediately. Now come to perpetuity. So I defined perpetuity already at the beginning of this video. So let me remind you once again. So far, when we were talking about annuity, we have seen that a series of level cash flows can be valued by treating these cash flows as an annuity, right? An annuity because the cash flow occurs for a certain time period. Now, an important special case of an annuity arises when the level stream of cash flows continues forever. Okay, and this is called perpetuity, and this is called perpetual cash flow. Okay, so perpetuity can also call consols. So particularly in the United Kingdom and Canada, there are consols, which are essentially perpetual bond, which means that if you invest in this bond, you continue to get interest forever. The principal won't be paid back, but the interest continues forever. Okay, and there is a pretty simple way to find out the value of a perpetuity. So look at this example. Suppose Gumdrops Limited wants to sell preference shares at $100 per share. A very similar issue of preference shares already outstanding has a price of $40 per share and offers a dividend of $1 per year. What dividend will Gumdrops have to offer if the preference shares are going to sell? Okay, Your current required rate of return is, you can see, it's a $1 per year, okay, and the price is $40, okay. So you can see that current required return is 2.5% per quarter, and dividend for new preferred share will be $100 into this 2.5%, so $2.5 per quarter. Okay, so the new dividend will be $2.5 per quarter. Now, if we want to find out the present value of a perpetuity, you can see the present value of a perpetuity can be found out using this formula. And preference share is an example of a perpetual cash flow because the dividend continues to come forever. Okay, now the present value of a perpetuity is C, which is the periodic payment. For example, it was $2.5 per quarter. Okay, so $2.5 per quarter, and the required rate of return, which is 2.5%. Okay, so 0.025. If you calculate this, you will find out the value of the share. Okay, so this is how we find out the value of a perpetuity, which is periodic payment divided by the required rate of return. Okay. So this is the end of this video. So in this video, essentially, we have learned about annuities and perpetuities and how to find out the value of an annuity, ordinary annuity, annuity due, and a perpetuity. Okay, so this slide provides you a summary that how you find out the value of a perpetuity using the present value factor or the future value annuity factor. Okay. So that's all in this video, and thank you very much.